Hello everybody! I'm happy to be a part of this showcase of approaches to digital humanities for researchers. I'm particularly excited to present you my project of digital mapping on which I have been working since 2018 in the Digital Studio. And the project is still advancing and evolving, bringing in more exciting challenges and opportunities to advance the field of digital humanities. Today I would like to present my project from the perspective of its contribution to the growing field of big data digital humanities and especially focus on three stages of the project progression from mere data aggregation to data intelligence. The first section, data aggregation, will expose a wide diversity of various data sets across urban and institutional domains to discuss several challenges of their consistent collection. The second part, digital visualization, will demonstrate how data visualization becomes the main method of analysis and research of cultural phenomena. Finally, the section, data intelligence, will share preliminary results of exploiting machine learning and algorithmic modeling to advance digital humanities research. Since 2011, the term big data has been exponentially spreading in the academic scholarship and the media. The Oxford English Dictionary defines it as data of a very large size, typically to the extent that its manipulation and management present a significant logistical challenge. Some scholars define big data as a twofold framework. On the one hand, it includes a large volume of data, reaching in some cases hundreds and thousands of terabytes generated by different actors per week. On the other hand, from the methodological perspective, the big data draws on quantitative analysis and visualization to identify meaningful patterns in order to create new knowledge. Research in big data digital humanities focuses on large or dense cultural data sets, which call for new processing and interpretation methods. To cope with data explosion, digital humanities has long supplemented traditional methods with computer-based methodologies that allow bird's-eye view at large data collections, thereby allowing the scholars to explore novel means to knowledge generation. Lev Manovich defines this intersection between data science and humanities research as cultural analytics, the analysis of massive cultural datasets and flows using computational and visualization techniques. This approach converts a mere data collection into a focused data analysis based on visual patterns recognition. This visualization and scalable interaction with the visualized material allows researchers to gain new insights about irregularities and disruptions that create new knowledge about various cultural phenomena. While traditional digital humanities scholars use computing to analyze mostly historical artifacts and digitize datasets of large corpora of cultural materials, the use of quantitative computational analysis in humanities outside of the historical framework has been steadily growing. In my presentation today, I specifically focus on the practice-based research project that stands outside of the historically oriented digital humanities. Instead, my project finds its inspiration in cultural analytics, in the sense that it is based on aggregating, exploring, analyzing, and visualizing big data generated by contemporary museums to ask and answer critical questions about their current and future audiences, institutional relationships, and most importantly, cultural, social, and even economic impacts at home and abroad. The project Deep Mapping trailed a pilot version of the dynamic verb application Museum Soft Power Map to enable museums to strategically use their cultural resources to assess, predict, and leverage their attraction power at home and abroad. It intended to address existing needs in the museum sector in cultural impact assessments by utilizing deep mapping to geo-visualize multiple quantitative museum data and tell stories about their institutional networks, communities, and global audiences. This creative practice-based research project was developed in partnership with the Australian Centre for the Moving Image in Melbourne. As a partner in the project, ACME provided access to its historical institutional records, including multiple data sets across its collection, visualization, programming, and exhibitions for the last 15 years. Specifically, this project contributed to research activities unfolded in the framework of ACME X Museum Incubator and Innovative Research Hub for Melbourne's creative practitioners, digital artists, producers, designers, web developers, and creative startuppers. In 2016, ACME partnered with the University of Melbourne to support academics like myself, doctoral students, and early career researchers to join the ACME X Incubator space to work on their digital practice-based research projects. The project on mapping museum soft power has become one of the exemplar models that emerge out of these cross-disciplinary collaborations that was designed on the one hand to address industry needs and on the other hand to contribute to the development of the theoretical field of digital humanities. From the practical perspective, the research partnership with ACME and the development of the pilot demo attempted to offer innovative digital tools for the use among museums to measure and map their local and global contribution to the creative economy and urban development. The research project Deep Mapping attempted to develop innovative computational methods that can visualize and assess the attraction power of museums. Contributing to the growing scholarship on cultural mapping, the project employed geo-visualization, data mining, and digital storytelling to develop a deep mapping application that can demonstrate museum global influence across 5 key layers of soft power, from mere resources to social outputs to economic outcomes. This system correlates multiple sets of museum collections, visitation, programming, and revenue data with demographic statistics and cultural analytics of specific locations, viewing them as politically, culturally, and economically defined locales. While addressing practical tasks in contemporary museology, the application also offered a promising tool for a more rigorous and in-depth analysis of theoretical and conceptual questions. Data aggregation is a premier fundamental level of digital humanities research that deals with the collecting of large-scale corpus of different types of data. This data ranges from digitized artifacts of born digital objects in possession of museums, libraries, or cultural archives to text, images, audio, or even geospatial data generated by users who interact with these objects either online, in closed digital environments, or on-site through different mobile applications. This interconnected digital data could be extremely diverse, big, and even fuzzy, and likely to be in continuous expansion that challenges the digital humanities research. The confrontation with the massive data calls for important questions. What can really be extracted from these huge data sets, and what interpretation can be drawn based on these extractions? The project Deep Mapping, developed in collaboration with ACME, started exactly from the point of identifying, categorizing, exploring, and collecting different institutional data sets that could be further analyzed and visualized. The multi-layered mapping project aimed to produce a system that allows a user to assess and visualize the influence of ACME on several interconnected levels. First, the soft power map application maps ACME film collection and calculates its potential appeal to national audiences in different countries around the world. The application also offers a way to explore ACME audiences ranging from on-site local visitors to online goers to the institutional website and to dedicated followers of its social media channels like Facebook or YouTube. It also exposes ACME international network of institutional connections and partnerships through global connectivity power layer that maps organizational ecosystem in the global context. Finally, the application enables an exploration of local impacts of ACME blockbuster exhibitions such as DreamWorks Animation and Game Masters touring around the world and assesses their local attraction power in different cities in Asia Pacific, Europe, and Americas. These multi-layered geo-visualization tasks required a focused work with a large amount of different data sets of data collected not only from the institution itself through various databases like Digital Collection Catalog, Google Analytics, Ticket Sales System, or even annual institutional reports, but also contextual data generated outside the organization. For example, one of the key layers of the soft power mapping system is Melbourne engagement power layer. This layer allows users to explore Acme attraction power to local audiences in Melbourne. On the one hand, it draws on the ticket sales data provided by Acme from 2011 until 2017 inclusive. This data combines quantitative information on ticket sales with geospatial data collected from Acme visitors by soliciting postcodes of their home locations. On the other hand, the layer geo-visualizes social, demographic, and cultural analytics data of urban neighborhoods across 200 postcodes in Melbourne. Not only this overlaying of data helps identify where the majority of Acme audiences or ticket purchases come from, it also illuminates who these people are, what languages they speak, or what religion they practice, among other characteristics. To explore a profile for each of the local communities of Acme visitors, the verb application aggregates and and maps multiple sets of Australian census data. This data includes social, demographic, and immigration statistics, cultural, linguistic, and religious diversity data, family and household information, professional affiliations, and income data, among other data sets. For example, one of the most involved Acme neighborhoods with up to 65% of local engagement power index is Little Italy, or the Italian precinct, located a famous Lagan Street in Melbourne and mostly known as the Italian community. It is situated in the suburb of Carlton with a postcode 3057. According to 2016 census data, apart from English, Italian language is the most spoken in the neighborhood, and the local population composition includes 11% of families with Italian ancestry and 4% of first-generation Italians, with many arrived in Melbourne in 2006 until 2015. According to the social demographic profile, the Italian community is a home of a quite wealthy population of younger age with high educational degrees and professional affiliations. The capacity of the local engagement power layer to expose this cultural and linguistic diversity information of actual and potential Acme on-site villagers can advance institutional capacities in audience engagement, as well as inform cultural programming, fundraising, and economic development. However, applying a finer-grained data with such a level of demographic detail for calculating local engagement power across 200 neighborhoods in Melbourne is not an easy task. It required an aggregation of reliable and consistent census data provided to the project by the Australian Urban Research Infrastructure Network. Aurin supported the project through data access and focused consultations on the intricacies of statistical geographic hierarchies, naming conventions, and algorithm of data aggregation that helped to organize the census statistics and apply the data for calculating of local engagement index. The result was the application's functionality to accurately map where Acme visitors live and link this information to important demographic and cultural diversity data. The experience of the Deep Mapping project demonstrates the importance of reliable and comprehensive data aggregation. This remains a challenging task for researchers who in many cases deal with non-consistent, not complete urban and state or even federal level data collected through multiple methodological approaches and which are very dispersed across different sources. While data aggregation stage is a foundation for a successful development and implementation of the big data digital humanities research, data visualization level is crucial to transform a vast amount of different data sets into a platform for knowledge generation. Data analysis through computational visualization is an important level of digital humanities research that can help produce new knowledge. This happens through a strategic data processing and targeted interpretation in a specific context driven by a project's key research goals and objectives. A key challenge in analyzing large data sets has been to transform the raw data into dynamically curated data, contextualized data, and deep knowledge. Big data visualization models and methodologies are quite diverse and complex and range from network visualizations to word clouds to mapping solutions that can be applied accordingly to generate the most critical insights and highlight important findings. The project Deep Mapping tested the soft power measurement framework and was predominantly based on geo-visualization of multiple sets of data to assess museum soft power. This approach applied geographic information system or digital system for handling, processing, analyzing, and visualizing a complex set of data that has a geographic dimension. Deep mapping is interdisciplinary methodology empowered by geographic information systems that facilitates the integration of different types of data through a cartographic display that aims to visualize and evaluate interrelations, coexistence, and process of complex phenomena. Deep mapping is a way to be conscious of a place in such a manner as to hold multiple layers of understanding of the present moment in non-reductive and robust manner. In the project of developing the soft power map application, the methodology of deep mapping provided an effective tool for an accurate integration, different sets of research data across museum resources, output networks, and epochs to expose correlations of data and processes happening on different levels of soft power analysis. In the project, the geo-visualization methodology, in fact, allowed the identification of measurable sources of museum soft power. At the same time, it helped reveal how these indicators relate to local factors which shape social and economic context of museum influence. Such a multi-layered mapping redirected the focus from simplistic quantitative assessments to the geography of museums' outreach and influence. Moreover, it allowed a visualization of museum global ecosystems, exposing rich connections, complex networks, and diverse areas of impacts. Furthermore, each of the layers in the geo-visualization system not only maps a certain dimension of the interinstitutional soft power, but also measures this power in different countries by calculating a power index. This index is a weighted sum of several key normalized indicators based on specific collection, visualization, or online engagement data in correlation to social demographic variables for each country or city. The scale from 0 to 100 for each of these indices progresses in a linear fashion, not logarithmically. For each layer of the soft power geo-visualization, the score allows a comparison of different countries in terms of the potential appeal of the collections to people living in this geographic area, its actual engagement with ACME activities, as well as its direct impacts. In this way, the score for each country in combination with color coding reveals geographic areas of missed opportunities and identifies zones of maximum influence. For example, the first layer collection appeal power index demonstrates the global cultural and linguistic diversity and scope of ACME collections, highlighting the geographic areas of their origins. The intensity of the green color on the global map allows the collection appeal power layer to visually highlight countries and geographic areas where the collection has the strongest appeal. Digital hyperlink stories attached to the most important content supplies help to explore further the ACME film archives, telling illuminating stories how the collection's items connect the museum to many communities and organizations across the world. The second layer, the Online Engagement Power Index, geo-visualizes the geographic diversity of Acme global online audiences. It shows the size and density of online website visitors as well as followers and subscribers to Acme social network spaces. The layer draws on the museum website visitation records and social media statistics collected from Facebook and also YouTube and TripAdvisor. The intensity of the blue color highlighting countries with the most engaged Acme online audiences enables a quick snapshot of institutional digital influence on the world map, demonstrating unequal distribution of power across geographic areas. The layer helps quickly reveal where the museum online visitors come from, while posing challenging questions about why audiences coming from certain countries are more engaged than others. The third layer, Global Connectivity Power Index, maps Acme international networks of partners, collaborators, and contacts that in the past decade worked with the museum on various cross-cultural projects, curatorial and artistic exchanges. The layer maps links between Acme and its 185 institutional partners in about 80 cities around the world on all continents. Not only it exposes the global ecosystem of Acme in terms of its institutional network connectivity, the layer also helps measure the strength and durability of these links, progressing from mere one-time collection exchanges marked as the weakest links to organizational collaborations and finally to long-term partnerships known as the strongest connections. The digital storytelling component accompanying this layer also helps illuminate details about historic collections of Acme across the globe through digital hyperlinked annotations, revealing interesting patterns, drawing meaningful insights, and generating new knowledge about the institutional performance across several layers of soft power. Works even more productively through a focused simultaneous correlation of data from different layers. This overlaying of multiple data sets allows a more accurate and in-depth insight generation, offering a more comprehensive picture. The Museum Soft Power Map application employs a geographic information system not simply as a set of tools to display data on museum cultural assets, activities, audiences, or networks, but primarily as an inductive, exploratory research platform that helps to articulate important questions and hypotheses requiring further research and analysis. It offers a knowledge system to provide an avenue for a long-term research endeavor to finally reach data intelligence. Data intelligence is a more advanced model of strategic data curation that enables organizations to explore, analyze, and organize large amounts of complex data, not only to assess their previous performance, but more importantly, to forecast and predict their future development. Scalable algorithms that employ data to extract insights and further build on recognized patterns significantly harness data curation architecture and improve the quality of generated knowledge compared to more traditional data visualization methods. While digital public humanities have been concerned with understanding and exploring cultural phenomena in the past, with the development of machine learning algorithms, big data digital humanities might reach a new level of data intelligence to envision a future development of cultures, societies, and organizations. Specifically, most recently, the Deep Mapping project employed algorithmic models of soft power evaluations, going beyond mere assessments of results accomplished by museums in the past. The project developed a prototype solution for predicting soft power of museum traveling exhibitions in specific geographic areas by prognosing how local variables of different locales affect and correlate with existing museum resources and targeted outputs to achieve desirable outcomes. This forecast system builds on data first collected and analyzed through the local engagement power layer that maps Acme traveling blockbusters in different hosting museums and cities around the world. Since 2012, 2 Acme blockbusters, such as Game Monsters and DreamWalk Animation, have been hosted by 16 museums in a dozen countries. This layer draws on a large amount of data describing local context of hosting cities and museums, including 3 types of key set of indicators: urban context, museum context, and attraction power. Urban context data includes multiple variables that reflect the level of the city's global exposure and cultural infrastructure correlated with the total urban population, migration, and tourist visitation rates. Museum context data shows quantitative characteristics of a hosting institution, demonstrating its international visibility and online representation and power. The attraction power data mostly consists of the statistics on visitors to this exhibition during the hosting period. In May 2019, the Museums of Power Map application launched a new layer, the Local Engagement Power Forecast. It predicts the soft power of the most recent Acme blockbuster exhibitions, such as Wonderland, that was exceptionally well received in Melbourne in 2018, inviting almost 200,000 on-site visitors. This layer forecasts the attraction power of this traveling exhibition in potential hosting cities across continents. Employing algorithmic modeling and drawing on the results of measuring the soft power of previous traveling exhibitions in different places, the mapping system calculates potential local impacts of the traveling blockbusters, taking into account multiple factors. Beyond the urban and museum context variables, this layer also draws on online engagement power and cultural relevance indices, adding more factors to predict the local attraction power. This allows a more accurate forecast of the attendance numbers of this exhibition to calculate its potential outcomes in different geographic locations. The local engagement power forecast is based on the prediction model of linear regression that combines a specific set of numeric input values to predict outputs. The forecast index draws on the supervised machine learning algorithm, a subset of artificial intelligence. This algorithm is closely related to computational statistics that makes predictions employing computing. It builds a mathematical model of a set of data that contains both the inputs and the forecasted outputs that consist of training examples, refined and upgraded each time when the actual outputs are received. In this way, this machine learning algorithm trains a model that dynamically processes new available data to make more accurate predictions. For example, among 17 potential cities where Wonderland might travel in the next decade, from Los Angeles to Taipei, the prediction model of linear regression forecasted Singapore and Wellington in New Zealand to be among the leading receiving cities in Asia Pacific, with the local engagement power forecast indices reaching 59 and 78 respectively. This forecast is based on the first iteration input data collected from a series of DreamWorks animation blockbuster exhibitions that proved to be highly successful among Asia-Pacific audiences. The Wonderland's actual visitation numbers, recently collected from Art, Science and Te Papa museums, in fact proved the forecast calculations to be quite accurate. The second iteration input information provided valuable data to feed the local attraction forecast machine learning algorithm that will obtain a high degree of precision once Wonderland and other future exhibitions of Acme will travel to other cities across the globe, generating different attraction power in different locations to supply more input data. In the case of Wellington and Singapore, the first results of the forecast algorithm, though convincingly proved urban and museum context data, as well as online engagement factors, to be important and useful variables that affect traveling exhibitions visitation and attraction power, making the forecast algorithmic modeling possible. While such data intelligence systems are in their infancy at the moment, they pave the way for a development of the big data digital humanities in the years to come. My presentation today aimed to demonstrate that with emerging projects like deep mapping, public digital humanities research acquires a new area of exploration, expanding the historical inquiry of cultural phenomena of the past to the new horizons of envisioning its future. I hope that my presentation today was not only useful and interesting, but also inspiring for further development of big data digital humanities research and innovative practices. Please feel free to connect me if you have further questions or you are interested in a potential collaboration. I'm looking forward to continue our conversation online, and I hope you will enjoy the rest of this very timely, interesting, and exciting event. Have fun!